Okay. So when we do the trig functions, there will be two different definitions. They're the same, but we just write them in different terms. There are 6 trig functions. There's sine, cosine, tangent, secant, cosecant, and cotangent. I will write them in a way that it makes sense to me. In the textbook, there's a table on page 27 that has them just listed. I try to pair them up so they make more sense. So we're first going to talk about a triangle. Yeah, that's fine. Thank you. I'm sorry, an angle in standard position. So standard position, remember, is the initial ray on the positive x-axis and the terminal side goes up. So the vertex is at the origin. So with that being said, if I were to draw this imaginary right triangle, which I've brought up to you before.
I had to bring your teas this morning.
Okay, so in this triangle, this point right here would be x units over and y units up, correct? Okay, so we're talking about the x-axis movement and the y-axis movement when we talk about this definition in the form it is. Okay, so we'll talk about the distance on the x-axis and the distance on the y-axis, which looks blurry to me. Is it blurry to you? Which will give us our functions. We did sine, cosine, and tangent last year. Not last year, 2 years ago in geometry. And we did sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. Probably don't remember that. Anybody in physics in here? No. Okay, so, but this definition is not opposite adjacent hypotenuse. It is in x, y's, and r's. So we have x, we have y. Well, r stands for what? Radius. We don't have a radius there, do we? But what if I were to do that? Do you have a radius?
Yeah.
The radius is the hypotenuse? Okay, so that's what everything is going to be in terms of, is x, y's, and r's. So theta is the central angle. The central angle, that's really small, sorry. The central angle see if I can write it a little bigger, is the angle between the initial and the terminal ray about the origin. Okay, it's the angle that moves about the origin. So we're going to start with sine, bless you, of theta. Sine is a function, so we take it of something, always. Like when we did a logarithm, we did the log of something, right? Mm-hmm. So we have sine of theta is y over r. And we are eventually going to write something over here. We're going to make 2 columns, okay? Cosine of theta is x over r. It's a ratio. It's a fraction. Tangent of theta is y over x, and x cannot equal what? What can't you divide by? 0. On this circle, where would x be 0?
Middle.
Right when I cross the y-axis, wouldn't it? Mm-hmm. Okay. So we have the basic ones you have heard of before, sine, cosine, and tangent. Now we have their reciprocals. Okay. So we have, and actually sine, guys, is S-I-N-E. The abbreviation is SIN. Okay? Cosine is actually COSINE. The abbreviation is COS. But when you see COS, you say cosine. Abbreviation for tangent is TAN, but obviously tangent is not spelled TAN. Okay? So we have the reciprocal of sine is cosecant. And it's abbreviated CSC. And it is spelled cosecant. So, yep, it's the reciprocal of sine, so it's what over what? R over y. And we probably need to say that y can't equal what? 0. Why didn't we say that r can't equal 0? Because it's what? Can a radius ever be 0? No. There wouldn't be a circle if it was, correct? So radius will never be negative and it never will be 0. It is a distance. Okay? So secant is SEC of theta. Is the reciprocal of cosine. Do you now see why we're writing them across from each other? So it would be what over what? R over x. And x can't equal 0. So the last one we have is cotangent, or COT of theta. So that's just co and then tangent. Is the reciprocal of what? It'd be, well, tangent was y over x, so it would be x over y. And y cannot equal 0. So we're in terms of x, y's, and r's because we're in a coordinate plane. We have a circle and a triangle in a circle in a coordinate plane. That's where we get our x, y's, and r's. Make sense?
Yep.
Okay. Some things that people tend to mix up. What do you think that people tend to mix up with, like the reciprocal of sine? Where do you think they go with that? Nobody? They want to say sine and secant and cosine and cosecant.
Yeah.
Okay. Think of it this way. Your pair can only have one co. So it's sine and cosecant. It's cosine and secant. It's tangent and cotangent. Does that make sense?
Yep.
The other thing is you can think is you can have an S and a C in your pair of reciprocals. You need an S and you need a C, not two S's, not two C's. Okay? Find some way to remember. You will figure out what a co-function is later on, and that's why they are named what the co part of it is. I do not know why the reciprocal of sine was named secant. I do not know why. I'm sorry, cosecant, or the reciprocal cosine was named secant. I don't know, but that's what it is. So how we use that, you'll have problems like find the 6 trig functions. So what are the 6 trig functions?
Sine, cosine, tangent, cosecant, secant, and cotangent.
Yep. Okay. Of theta, and it goes in detail, of theta, if theta is in standard position, why is it important to know standard position? Where does it put the vertex? 0, 0. And the point -2, 3 is on the terminal side of theta. Okay, so now do you know why the definitions we've had to go through the last couple of days? Like, you need to know standard position, you need to know terminal side. Okay? So what quadrant does theta lie in?
2.
2. Why?
Because it's negative x positive y.
Negative x, positive y. So the first thing you're going to do is draw yourself a picture. It doesn't have to be a big picture. It doesn't have to be a great picture. It just has to be a picture. Here. And I have some point on it. And it's -2, 3. So my angle goes like this, right? So this is theta. Okay. Now, we probably should make what?
Circle.
You can make a circle, but you don't have to. Okay? If you want to make a circle, you can. I'm more concerned about the right triangle. Know that the circle is there. That was not good. There. There's better. Know that the circle is there. I'm more concerned about the triangle. Okay? So, in your assignment today, when you do these, you're going to write x over r, y over r, y over x, x over y, every single time you do it. Why am I going to do that? So it gets stuck in your brain. This is the chart, guys. This is the chart that you have to do in your final. Okay, so I have -2 and 3. So what parts of my triangle do I have? What's the x? -2. So I put a -2 because that would be the bottom of my triangle, correct?
Mm-hmm.
And what is the y?
3.
3. So I'm going to put it over here. So my legs of the right triangle are -2 and 3. Well, I need to know r. How do I find r?
Pythagorean theorem.
Pythagorean theorem. The whole purpose of that Pythagorean theorem assignment was so you could basically do it in your head. When you were done with it, could you just like blurt it out? You were writing very little, hopefully.
I don't have to write very much.
So r equals the square root of what? 4 plus 9? So the square root of 13? So the square root of 13. Now that I have my x, my y, and my r, am I ready to find all 6 trig functions? Okay, so the sine of theta equals what variable over what variable? Y over r, which equals 3 over the square root of 13. Can I leave it 3 over the square root of 13? Nope. How do I take care of that? Guys remember? The square root of 13? And that's called rationalizing. And so you have 3 square root of 13 over 13. Now, after today, I would assume I probably don't even see this step right here. I would assume you would go 3 over the square root of 13 and then just write 3 square root of 13 over 13. Because that's what's going to happen every time, right? Sometimes we could reduce afterwards, but we can't reduce the 3 and the 13, can we? Okay, so do you want to go right away and do cosecant? Okay, so I would write it next to it. So cosecant of theta, because we don't know theta, but we still have to put it, is what variable over what variable? R over y. So r is square root of 13, and y is 3. Now, you could look at sine and just reciprocate it, yes?
Mm-hmm.
But what if you messed up sine? Would you mess up cosecant?
Mm-hmm.
Yes. Whichever way. I can't stop you from doing it either way. So cosine is what over what?
X over R.
X over R. X is -2, and R is square root of 13. Do I have to show the rationalizing, or can I just go -2 square root of 13 over 13? Can we can jump? -2 square root of 13 over 13. So what would we logically do next? Secant. And secant of theta is R over X.
So square root of 13 over -2.
Yeah, and I'm going to write it negative square root of 13 over 2. The reason, no, you don't have to. Does it look funny to have a negative in the denominator? Okay, so then put it in the denominator. To me, it looks funny. Okay, when I see secant by the end of today, should I know it's R over X?
Mm-hmm.
Yes. Should I also know that R is never negative? Yes. So when I see that, I know the negative belongs on the 2, but I just don't like to write it there. But if you don't mind a negative in the denominator, you go for it. I can't handle it. Do you guys want to do tangent on your own?
Yeah.
Okay.
That was easy.
Okay, so did you get -3/2 and -2/3?
Mm-hmm.
Okay, so the other thing is, again, on tangent, I put the negative in the numerator, but I know that theta lies in what quadrant? 2. Okay, so, and I know that this is y over x, so what should I know the negative is on? The 3 or the 2? The x or the y? The 2. I should know it's on the x because in the second quadrant, x is negative. Correct? Lies in. That was yesterday. Trying to see how much we need to do. Because I want to give you time to work.
Was this all we're basically doing?
Basically, they'll have some problems that make you think a little bit. But other than that, yeah, basically.
Can we start on it?
We'll do one more. Just because. And a chart. And then, yes. Okay, so all 6 trig functions of 270. All 6 trig functions of 270. So the first thing I'm doing, I'm going to draw me a little picture, right? And if you want to draw your circle, draw your circle. I just have to do them first. So 270 is right there, yes? Okay. So I don't know how big this circle is, do I? No. But if R equals 1 unit, whatever that unit may be, okay? So R equals 1. Make sense? So if R is 1, what's this point right here? What's that point right there?
0, 1, maybe?
It's 0. I'll go with 0. What?
0, 1.
Negative 1.
Yeah.
Why is it negative?
Because it's
Going
down.
down, yes? So my R is 1 unit, and I have X is 0, and Y is what?
Negative 1.
Negative 1. So do I have my X, Y's, and R's?
Yeah.
Yeah. So do you want to do all 6 real quick?
That's something we can't do.
Just both?
Because X is 0.
So what do you put then?
I don't know.
Start doing them. And remember to redo your X over R, Y over R, R over X, all those every time today. It's going to get really tedious, but by the end of the assignment, should you know what you're doing?
So R is 1.
Yep, R is 1 unit. Yep.
I keep wanting to put parentheses instead of a thing.
Parentheses on what?
Like, because of.
Okay, and I will tell you, we will do that. When we have like an actual number, we will have parentheses there. So if you want to put parentheses, you're totally fine to do. Because that's what the of means. You are right.
Because I keep wanting to do it.
Nope, so go for it. Because we will do that eventually.
Oops. So what if I do if it doesn't, if the X is 0?
Oops. So I didn't finish. Oh, sorry. Alex, are you close? Okay, I'll wait.
Yeah, I'm done.
Okay, what did you guys put for secant and tangent?
I just put
Just
1
right.
over 0.
Okay, it's not 0.
My bad.
It's just like undefined.
It is undefined. So we write U and D. U and D. So if I look at this, guys, the reciprocal of 0 is undefined, yes? What's the reciprocal of undefined? 0. So we've been trying to divide by 0 for a long time, and every time we do, we just put what? Undefined. So we cannot find the tangent or the secant of 270 degrees. Now we can't put 0 because 0 is 0. And again, that's like, okay, here's this pin, divide it 0 ways. I haven't developed my magic skills yet. Not ready for Hogwarts. So this pin is going to be here. I cannot divide by 0 in any shape, way, or form. Okay, the last thing I want to talk about is where these things are positive and negative. They rely on in which quadrant. If we're talking about X and Y's, don't they rely on where the X and the Y's are positive and negative? Okay, so the book has like a square chart. I like to make a round chart. A round chart. I like to make ourselves, well, not even a round chart, just a coordinate plane.
How big?
Oh,
My hand
I don't know. Mine's gonna be that big.
I draw big.
Okay, you draw big. So, this is my coordinate plane. This is Q1, Q2, Q3, and Q4. Yes? This is a positive x-axis, a positive y-axis, a negative x-axis, and a negative y-axis.
Yeah.
So any point in the first quadrant is going to be, in terms of positive, negative, is going to be what and what?
Positive.
Okay, it's going to be positive, positive. And in the second quadrant, it's going to be what?
Negative. Positive.
Negative, positive. Because y, x is negative, y is positive.
Mm-hmm.
In the third quadrant, it is going to be
Negative. Negative.
negative, negative. And in the fourth quadrant, it is going to be
Positive. Negative.
positive, negative. All determined on the axis that we're meeting up with, correct?
Mm-hmm.
Okay, so sine of theta was what? Whatever what?
Y over
Y over r. Cosine
X over
x over r. If you know sine's y, you should know cosine's x, correct? Okay, a lot of things I'm going to tell you guys, if you know this, you know that, because you don't want to have to remember everything individually. Does that make sense? Okay, and tangent is y over x. Okay, I write sine, cosine, tangent. Look, y over x. Tangent, y over x. That's why I write it the way I write it. Okay. When I talk about sine, I'm talking about which x or y?
Y.
Y. When I'm talking about cosine, I'm talking about x. When I'm talking about tangent, I'm talking the ratio of y and x. So anytime I say sine, you should think what variable? Y. Anytime I say cosine, you should think x. The positive and negative x and y determine whether the sine, cosine, or tangent are positive or negative. Got it? If sine is negative, so is cosecant. Because they're what of each other's? Reciprocals. So I'm not going to remember cosecant. I'm just going to remember cosecant's the reciprocal of what? Sine. Does that make sense? I'm not remembering 6. I'm remembering 3. Okay. So which sine, cosine, or tangent are positive here in the first quadrant? All of them. Because x and y are both what? Positive. So all are positive. So in the second quadrant, what's positive in the second quadrant?
Sine.
Sine. And that's it. So sine is positive, and cosine and tangent are negative. And why? Why are cosine and tangent negative?
Because they both have an X in them.
They both have an x in them. Okay, so what is positive in the third quadrant? Nope. X and y are both negative, so that would make tangent positive. So tangent is positive, and sine and cosine are negative. I'll put the parentheses around it. So if you remember what's positive in that quadrant, isn't everything else what? Negative. And again, I'm not talking about the reciprocals because the reciprocal follows their match. Okay. So what's positive in the fourth quadrant? Cosine, because it's positive x. So cosine is positive, and what's negative? Sine and tangent. Now, when I talk about this, guys, I'm really just going to say which one's positive. Because again, if you know what's positive, then you also know what's negative. Okay? Why is cosine positive in the fourth quadrant? Because the x is positive. Why is tangent positive in the third quadrant?
They're both negative.
Because x and y are both negative. You get the connection. Any questions on that? Okay. I think we're good. The last couple may stretch your brain a little bit, but I don't want to keep doing examples. Well, there's only one more example
No.
for even Monday, but okay. So I can't read the assignment. The computer door's in the way. So you have the rest of the time to work, and it is going to be find the 6 trig functions. What if they give you one trig function? Can you figure out the rest?
Yeah.
Because you should be able to make a triangle, shouldn't you?
Yeah.
Yeah. If they give you one trig function, you make a triangle and you find all the rest. So make sure you know what quadrant it's in.